is trying to get you to compare expressions, and they want you to get used to some of the rules. We already had the rule if my bases were the same, x to the m times x to the n, I add my exponents, x to the m plus n. They're also going to give you the rule that if my exponents are the same, if I have x to the m times y to the n, oh nope, I want to use n. My exponents are the same. So x to the m times y to the m, you're going to get x times y to the m power. So I multiply my bases and keep that exponent. So looking here on this one, I have 2 squared and 4 squared. My exponents are the same, so my rule is to multiply my bases. 2 times 4 is 8, and I keep that same exponent. So I'm going to get 8 squared. 8 squared compared to 8 to the 4th, going to be less than. Here, on this one, this is the one where my bases are the same, like we did up here. 2 to the 4th, 2 squared. My rule is to add those exponents. So 4 plus 2 would be 6, so I would get 2 to the 6th power. 2 to the 6th compared to 2 to the 8th, going to be less than. Now on this other one where you don't have a common base and you don't have a common exponent, basically you just have to figure it out. 2 to the 4th is 16. 4 squared is also 16. Well, that's going to be 16 squared. 16 squared compared to 8 squared, well, 16 squared is definitely bigger than 8 squared. You could even go farther than that if you wanted to use your calculator and figure out what 16 squared is and what 8 squared is. I got to grab my calculator quick here. So, 16 squared would have been 256, and 8 squared would have been 64, and yes, we know 256 is bigger than 64. So basically on that bottom one, you just have to do your calculation until you can tell which one's bigger or which one's smaller. On the other two, they're going to be using one of these 2 rules. If my bases are the same, I add my exponents. If my exponents are the same, I multiply my bases and keep that exponent. So number 8, I'm looking at that. I have 2 to the 3rd times 2 squared. My bases are the same. My rule is to add my exponents. 2 to the 3rd times 2 squared would be 2 to the 5th. 2 to the 5th is going to be less than 2 to the 6th. On the next one, my exponents are the same. If my exponents are the same, I multiply my bases. 2 times 3 is 6, and I keep that exponent, so I'm going to get 6 squared. 6 squared compared to 6 squared, going to be equal. The next one, 2 to the 3rd power, 3 squared, neither are the same, so 2 to the 3rd is 8, 3 squared is 9, 8 times 9 is 72. 6 to the 6th power, I don't know what it is in my head, but I know it's going to be really big. 6 times 6 times 6 times 6 times 6 times 6. If I got them all in there, I've got 46,656. Obviously 72 is going to be less than that. Should use my other calculator where I have my exponent key instead of having to do it the long way. 6 to the 6th power. The next one here, I've got 3 to the 3rd and 5 to the 3rd. My exponents are the same, so I multiply my bases. I would get 15 to the 3rd. 15 to the 3rd is going to be less than 15 to the 5th. On this one, my bases are the same. 3 to the 5th and 3 to the 3rd. If my bases are the same, I add my exponents, I get 3 to the 8th. 3 to the 8th compared to 3 to the 15th, going to be less than. And then here's another one where I just basically have to calculate that out. 3 to the 5th is going to be 243 times 5 to the 3rd. 5 to the 3rd is 125. 243 times 125 is 30,375. On the other side, I'm going to do 15 to the third power. 15 to the third power is 3,375. So we can see that 30,375 is greater than 3,375. And really on all of these problems, you could do the calculations and compare your two answers. They're just trying to give you a shortcut where you don't have to do all the multiplying out and figure out what the numbers are by either, if my exponents are the same, multiplying my bases, or if my bases are the same, adding my exponents and giving you a little shortcut. Number 10.